Welcome to the physics session, BSc, third semester, paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, Unit 3, Theory of Dielectrics and Moving Coil Galvanometer, 14th session, we learnt about charge and current sensitivity and their relationship, measurement of capacitance of the capacitor by absolute method using the ballistic galvanometer. Now we can see the definition of the sensitivity of the instrument. So sensitivity of an instrument it is the by the minimum input for a standard output. Minimum input for a standard output. The standard output for a galvanometer is the deflection in 1 millimeter on a scale of 1 meter away. The input is the current or the charge through the galvanometer. So now we can see that here we can see the deflection of the galvanometer by applying the electric charge. By applying the charge, the deflection of the galvanometer will be obtained. So we can see that how to deflection will be obtained. The charge or the ballistic sensitivity is charge or the ballistic sensitivity may be defined as the quantity of the charge that is required to produce a deflection of 1 millimeter scale in 1 meter away from the suspension of the galvanometer coil. It is given by the formula S subscript Q is equals to Q dividing by theta, which is equals to T dividing by 2 pi into C dividing by NBA. This is call it as an equation 1. It is derived from the moving coil ballistic galvanometer in the previous class. So now we see the current sensitivity or figure of merit. Current sensitivity or the figure of merit. Current sensitivity or figure of merit of a galvanometer, it defined as the quantity of current required to produce deflection of 1 millimeter on a scale 1 meter away from the suspension of the galvanometer coil. It is given by the formula SI. I means current subscript. So which is equals to I dividing by theta. This given by the formula C dividing by NBA. So the relationship between charge and the current sensitivity is given by from equation 1 and 2. SQ is equals to T dividing by 2 pi times of SI. Means time T is the time period of the coil. This the relationship between charge sensitivity and current sensitivity is charge sensitivity is equals to T dividing by 2 pi times of current sensitivity. So next we coming to the measurement of capacitance of the capacitor by absolute method using ballistic galvanometer. So now we can see the diagram of circuit diagram for that capacitance determination. So here C is the capacitor and G is the ballistic galvanometer, K is the plug key, small r and capital R is the resistance, and capital E is the applied EMF. So here the construction of the circuit diagram, it represents capacity of the capacitor is used to measure in the circuit as shown in the figure. So here Morse key will be used to charge and discharge of the capacitor through ballistic galvanometer. K is the galvanometer damping key and discharge capacitor through the ballistic galvanometer and discharge the capacitor from the through ballistic galvanometer. Capital R is the high resistance and its value is equals to 10 kilo ohm, and small r is the standard resistance which has an 1 ohm. Procedure how to determine. So initially K is kept at open. K is open and knob A is and mercury will be knob A of the march key A will be pressed down. The capacitor of is charged with the potential difference. V is, you know that Ohm's law, V is equals to I into R. Charge on capacitor Q is equal to C into V. From the above equation, V value will be substituted. Q is equal to CIR. C is the unknown capacitance. So A is already is discharged through the ballistic galvanometer. It produces the deflection on theta 1. Therefore, now we charge the ballistic galvanometer. Q is equals to T dividing by 2 pi into C dividing by NAB into theta 1 plus lambda by 2. 1 plus lambda by 2. Here, where T is the time period of the coil and C is the rotating coil constant, A is the area of the coil and B is the magnetic field strength, lambda is logarithmic decrement. So, from the equation 1 and 2, left hand side will be same. Therefore, equating the above equations, we get CIR, which is equals to T dividing by 2 pi into C dividing by NAB into theta 1 into 1 plus lambda by 2. Therefore, theta 1 is equals to, rearrange the above equation, we will get I dividing by 1 dividing by 2 pi C dividing by NAB into theta 1 plus lambda by 2 I into R. So, now we will get the equation. Now the K is closed. A steady deflection in the theta 2, it flows through the ballistic galvanometer. It produces steady deflection theta 2. Then at equilibrium, deflecting couple is equals to restoring couple. We will get NFG into theta 2 is equal to C into theta 2. Therefore, theta 2 is equals to C dividing by NAB into 1 by theta 2. If G is the galvanometer resistance, then current Ig through the galvanometer is Ig is equals to voltage across the ballistic galvanometer through the total resistance IR dividing by R plus G, which is nearly equal to IR dividing by G, because small r is negligible, small compared to the G. Therefore, substituting this equation into this equation, we will get IR dividing by G theta 2, which is equals to C dividing by NAB, which is equals to IR dividing by G theta 2, which is equals to C dividing by NAB. Now, from equation 3, 6 and 1, we will get the equation capacity of the capacitance of the capacitor. C is equals to T dividing by 2 pi eta dividing by GR into theta 1 dividing by theta 2 into 1 plus lambda by 2. Now we can see the one problem based on the galvanometer, that is a capacitor of a capacity 0.2 microfarad is charged to an 2 volt and is then discharged through a ballistic galvanometer. The corrected deflection is recorded by the galvanometer is 10 units. If 12 is be the periodic time, calc 12 seconds. Be the periodic time, calculate the current sensitivity of the ballistic galvanometer. The solution is charge flowing through the galvanometer is given Q is equal to C into V. Here C is the 0.2 into 10 power minus 6 farad, 0.2 into 10 power minus 6 farad. V is the 2 volt and alpha is the 10 units, t is the 12 seconds. Alpha are in our textbooks we measure theta. Alpha is equals to theta. Now we can charge Q is equals to T dividing by 2 pi into K into alpha. Therefore, the current sensitivity is equals to K is equals to Q dividing by T into 2 pi dividing by T into alpha. Q is the C into V. Substituting this equation, we will get Q divided Q value, which we will get C into V dividing into 2 pi dividing by T into alpha. Q is the 0.2 into 10 power minus 6, V is the 2 volt and 2 pi is the 3.14 dividing by T is the 12 into 10. We will calculating above this equation, we will get the answer K is equals to 0.0104 into 10 power minus 6 amperes. Thank you for watching.